Within machine learning, there are several different ways to teach a machine learning algorithm, and there are many different training techniques you can utilize, and there are many different ways that you can configure the model itself. As the technology progresses, more is learned about the individual strengths and weaknesses of individual training techniques, model configurations, etc. One such technique is called a GAN, General Adversarial Network. This particular training technique, and what happens during and after the training, is why I am convinced that no algorithm will ever be invented that will actually solve this particular problem. Many companies have tried to release products in this area claiming they have solved it. I have done some research into trying to solve it myself. It seems like an easy problem on its face to solve. When you break down how machine learning actually works and how this problem presents itself within that framework, though, it becomes what I believe is a 100% impossible equation to solve. The fact that it is impossible to solve is built into the equation itself. Generative adversarial networks (GANs) are a type of machine learning model that involves two key components, a generator and a discriminator. The generator is tasked with producing synthetic data, such as images, while the discriminator's role is to distinguish between real and fake data. These two components work together in a competitive manner, continually improving their abilities through a process of iteration. The adversarial dance: imagine a scenario where an art forger, the generator, creates counterfeit paintings, while an art critic, the discriminator, tries to spot the fakes. The forger learns from their mistakes and attempts to produce more convincing counterfeits, while the critic sharpens their discerning skills to better identify the fakes. This back-and-forth dance between the forger and the critic is analogous to the interplay between the generator and discriminator in GANs. To train a GAN, the generator and discriminator are initially pitted against each other with limited skills. The generator produces random samples, which are then presented to the discriminator along with real data. The discriminator's goal is to correctly classify the samples as real or fake, while the generator aims to fool the discriminator by generating samples that resemble real data. As training progresses, both components gradually improve their abilities through a process of adjustment and refinement. As the training proceeds, the generator becomes more skilled at generating synthetic data that appears increasingly authentic. Eventually, the generator becomes adept at producing samples that can deceive the discriminator, making it challenging for the discriminator to distinguish between real and fake data. At this stage, the GAN is said to have reached convergence, and the generator has become a proficient artist capable of generating remarkably realistic outputs. Once the generator reaches convergence, the discriminator doesn't stop working entirely. Its purpose shifts from being an active learner to serving as a quality assessor. The discriminator continues to evaluate the samples generated by the generator, but its primary goal is no longer to improve its discrimination skills. Instead, it focuses on providing feedback to the generator regarding the quality and authenticity of the generated data. The discriminator's feedback serves as a valuable signal for the generator to refine its output. By analyzing how the discriminator perceives the generated samples, the generator can adjust its parameters and fine-tune its generation process to produce even more realistic and high-quality data. The discriminator acts as a critical guide, helping the generator to continually improve and enhance its creations. In essence, the discriminator's role in a GAN evolves from an active participant in the adversarial game to a critical evaluator and mentor for the generator. In a GAN, the discriminator starts out with the advantage: it is used to train the generator. The generator continually improves its ability to generate content that is indistinguishable from human-generated content until it can continually fool the generator. Once this process occurs where the generator can fool the discriminator with consistency, the discriminator model starts to collapse. Which gets worse and worse at discriminating between real and fake content the more it guesses wrong based on what the generator produces. In turn, the generator takes in feedback from the discriminator, learns what it looks for, and adapts from that, continuing the feedback loop where the generator gets stronger and the discriminator gets worse and worse at its original job. Eventually, the discriminator simply begins flipping coins, essentially to make predictions. Any AI algorithm that is designed to attempt to detect AI-generated content is essentially going to be the discriminator in a GAN. That would be the exact function you are requesting it to do. That could not be removed from the equation without changing the function you ask the model to perform. That model will inherently need to discriminate content that is explicitly created by GAN models. Many image generation and some text generation models are trained utilizing GANs. It would be impossible to not feed the model data that is created by a generator within a GAN if you are asking the model to determine whether or not content is AI or human generated. This process will always create the feedback loop between the generator and the discriminator. Even if the discriminator starts out able to predict the content from the generator with high levels of accuracy, the generator can always simply utilize this feedback to easily make adjustments to fool the discriminator, especially in instances where we are referring to Chat4 or even Llama as the generator. The end result will be a product that trains Chat to get even better at generating realistic content that cannot be distinguished between human written and AI written. The more you try to tackle the problem in this way, the stronger you make AI at getting around the problem. How do you exit that feedback loop? I do not know. Not through any prediction algorithm though, I know that much. That also means the actual solution, if it exists, will be something very outside of the box. In the meantime, anyone at all who makes claims that they have created a prediction algorithm to solve this specific challenge is lying. It goes wholly against everything we currently know about training these algorithms and models. Of course, people want it and want to lay claim to it. It is a golden goose for whoever solves the problem. It is very important to note though, this particular problem is far more complex than it appears to be on face. Anyone who says they have solved it should have their work heavily scrutinized before largely publicizing such claims. It only sets back the technology and the industry as a whole to do otherwise. It presents multiple scenarios in which the industry presents a promise to a problem that it cannot actually currently solve,